Okay, so now going to the SIP headers and take care of these SIP headers. There are some SIP headers, so let's revert back to the trace before going inside this. So when we said here, we can see inside this is the register request here. This is the request line that identifies. Then this another part is the message header. This message header part is present in both in the request and in the response. So this message header describe what's present inside the request and what's present inside the response. Yeah, so you will find here maybe the same or near headers, most of them. So there are 5 SIP headers that are mandatory. You must add them. If it's not present, then this SIP request will fail. Okay, so what are these SIP headers? First, you have the from. The from, if you look here, this is the from. The from specifies the sender of the SIP request or response. Okay, and actually also there's a to header that specifies also, but this time the recipient. Yeah, but the recipient for what? So let's try to think about it. Yeah, so this is describing a session, a call. That's the user a number. So this a number is a from in the from header, and the b number inside the to header. Yeah, that makes sense. But if it's a registration, yeah, so we here making a registration. So is the from and the to also will be present? Yeah, they must be present as we mentioned. So now they include here the same a number. It's not including the b number. So there is no b number in registration. It's just the user is trying to register. So yes, this from and the to are present for that purpose. And this yes is according to RFC 3261. You can revert back for it. I hope you have downloaded already. Yeah, so there is a CSEC header. Yeah, and before going to the CSEC, just I want to talk about the call ID, and that's preferred for me. So the call ID, you can see here, this was called a call ID, and this we can right click on it and apply as filter and then select. So we have here certain call flows, about certain call flow that's being sent. So if you can look here, there is certain call flow that's being only filtered inside this Wireshark trace, and this call flow is a complete this call flow is complete registration for this handset and what happened inside it. So there are other packets in the trace that are not related to this registration, so they are filtered out, but this is only present because it present the registration call flow or this call flow. So if you want to filter on a specific call, then we can say a call flow, not a call, because this is a registration call flow, so I'm filtering on it. If you have another invite which contains a certain call, then yeah, you can right click on the call ID, apply the filter. This identifies only this call. Okay, so this is uniquely identify a SIP call or dialog. All SIP messages related to the same call have the same call ID value. Okay, this is a call ID. And then we can go to that CSEC that I skipped it because this CSEC represent only a sequence number of a certain SIP request and its response. So we can do like something like this, a SIP register request. We can apply as we can go to the CSEC header here, and then after that you find here one register, so apply as filter and then select. So this is only selected, so this what was present. So so it can happen that the register is sent inside a certain call flow for more than one time. Actually that's what happens. So this CSEC this may be not complete registration call flow. I can present a new one, but in that case, that's why the CSEC is only representing this register call flow. So anyway, the CSEC identifies a certain sequence number for SIP request within call or dialog. So this register has been sent from this UE to that node, and then from this to this, and then there was a response for it with 401 unauthorized. So all this happened for the same register request. But if this call flow is completed, you can find another register request with a different CSEC, but the same call ID. So the call ID will filter on the whole call flow for this registration, but the CSEC will only filter on specific request with its response. So again, here showing the difference between the CSEC and the call ID inside this trace, which contains all the registration packets. The last one was missing some packets. So we want to filter on only one call flow. What we will do, we'll go to this register request as an example, as it's starting here, and we will go to the call ID and then right click and then apply as filter. So you can see only these packets are present. So there are packets that have been removed, okay, and only these are the packets that belongs to the same call flow. Okay, so this is the call ID, and we can see inside the same call ID there are two register requests. So this is the first register request that was replied with 401 unauthorized, and this is another register request that was replied with 200 okay. So you can see in the first register request the CSEC here is one register, and in the second ones is the CSEC here is two register. Okay, so going afterwards, we have a via header. So this register request is moving on a certain path. We can say it goes from the UE to the proxy CSF, and then from the proxy to the S, and then whatever the path it's moving towards it, there is a, we can say here, a via header that record every hop it passed by it. So you can see here inside it here, the via header is recording this IP, and if we go to know what is this IP, you will find it here. This IP is, yeah, here's it, this the proxy CSF hop. So yeah, I want just to mark that I passed by the proxy CSF, and I will mark that, I will record that in the via header, because when the response is I have a response from the far end, then I will move in the same path that's present inside the via header. I can see here the 10.0.190.99. This was, I received the request from this IP, then I will go in the response towards this IP that was saved here in the via header. It's something like I am I'm recording the path I've moved through it in a paper. This paper is the via header. So when I finish my request, I will go in the same path through this via header. Yeah, so these are the 5, and then there's a maximum forwards. Yeah, and this maximum forwards indicates the maximum number of hops or a SIP request can pass through. Okay, so where is the maximum forwards? We can see here, look inside this, there is a maximum forwards. Okay, one sec. Yeah, here's it, the first ones. The maximum forward is 69, yeah, but look, before it, the maximum forward was here, 70, okay? Yeah, here, 70. So 70 maximum forwards on the first request, and the second, and the same request is being sent to another node, it became 69. So it's like counting down. What is this maximum forwards? The maximum forwards is a method that is being used to avoid a loop. Yeah, so imagine with me this register request sent from here, this UE, or from whatever node to another node, and then for some reason there was an error, and when it reverted back, it had a loop, like is the request is being sent again and again, and then the response is being received again and again. So imagine with me that happens for several requests, though this can make a problem, increase the CPU load, and the nodes have problems. So I need to stop this request from being processed anymore. So how that is done? That's done through the maximum forwards. The maximum forwards is putting a maximum number of hops this request can pass through before being discarded. So if you exceeded the 70 number of hops, I can tell you easily that this request will fail. Okay, so and it will fail intentionally because the maximum forward has became 0. So it cannot be processed anymore. Yes, so these are the zip headers that are mandatory, and we need to know, you can refer back again to the RFC 3261 to see every detail about them.